All right, this is the last video of lesson 6.1, and it's on investigating scatter plots. So we just ended up making some predictions based on our lines, our graph, the graph of the line of good fit, our equation of our line of good fit, and then the equation of the line of best fit. Okay, so when you use your equation or your graph to make some kind of predictions for values that you don't know, that's called interpolation or extrapolation, depending on what you're doing. So when you interpolate, you are making a prediction within the data. So if I go back to the graph and I draw a little box, I'm going to draw this box in green, around the data points. So my data points, and it has to be a box. Any prediction that is made outside or inside that box is called interpolation. So any age that's between 1 and 8, or any height that's between 70 and 135, that is called interpolation. It's within the set of data. So, for instance, when we looked at how old was Julie at 100 centimeters tall, that's within that range of 70 to 135. That would be called interpolation. So when we calculated the 4.2 years, the 4.1 years, and the 4.1 years, that was all interpolation. Or, how tall was Julie when she was 5 years old? Yes, we had a number. We had an actual number of how tall she was. She was 106 centimeters tall. But according to my line of best fit, I said she was 108. According to my equation of good fit, 108.8, and the equation of the line of best fit was 108 as well. This is all 5 years old is between 1 year and 8 years. So that is also interpolation. These predictions are usually reliable. Do I need to do that in a different color? I think I do. Let's go back to purple again. These predictions are usually reliable. They're fairly close. Now, we did have numbers for exactly 5 years, but what if I wanted to know how tall she was at 3.5 years old or at 6.5 years old? That's all within the data. It's not data points, but it's on that line of best fit within that box. When you extrapolate, you are making predictions beyond the data. It often requires you to extend the line. These predictions are usually less reliable. So anything outside the box, so I'm going to change colors here. I'm going to go orange. So how tall was Julie when she was 11 years old? 11 years old is over here. It's outside the box. All right, so then we get this prediction that's way outside the box. Or the question about how tall was she when she was born? That is outside that box. So that is called extrapolation. We have to extend the line outside of our data. Not outside, it doesn't mean it's the graph, it's outside of the data. That box that has all of the data inside it, it's outside that box, which means it's called extrapolation. Okay, so how tall was Julie when she was 5 years old? What type of prediction is that? That was interpolation. How tall will Julie be when she is 11 years old? That's extrapolation. How old was Julie at 100 centimeters tall? That was interpolation. That was inside the box. And how tall was Julie when she was born? That's extrapolation because that was outside the box. Okay, so there was some stuff about interpolation and extrapolation in the online activity as well. But hopefully you may understand it a little bit better now. All right, last thing. This was in that activity was correlation. A scatter plot shows a strong linear correlation when the points closely follow a straight line. If all the points follow exactly on the line of best fit, the correlation is perfect. So this is not a perfect straight line. It's so darn close to it. So this is what we would call strong. A scatter plot shows a moderate or weak correlation. This is strong. When the points follow a linear trend, but they are more scattered away from the line of best fit. This one that's demonstrated here would be what I would call moderate. It wouldn't be weak. You would need a few more points outside. If I plotted those extra points there, now that's getting to be closer to weak. I still see a falling trend, but it's a really wide falling trend. And in the activity, they talked about drawing an ellipsis or an oval around your data set. The wider the oval, the weaker the correlation. So the oval for this first one is going to be really, really skinny. So that's strong. The oval for the actual data set would be like this. That is moderate, but then with the data points added, if I consider all those data points that I added, now we're getting into weak. Okay. And a scatter plot shows no correlation when no pattern appears. Like I don't see anything increasing or decreasing here. I can't tell if the points are falling or if they're rising. They just seem to be all over the place. Okay, and I draw something around this. If all the points are roughly enclosed by a circle, then there is no correlation. Oh, back here. If you visualize an oval around the points, the thinner the oval, the stronger the correlation. A fat oval would be weak, a medium-sized oval would be moderate, and a thin oval would be strong. And then we also talk about positive or negative correlation. So if the points rise to the right, the correlation is called positive. And if the points fall to the right, so that means it's got a positive slope, sorry. And if the points fall to the right, that's called a negative correlation. So they're coming down. This means that one quantity increases. As one quantity increases, so as the independent, the dependent decreases. And for positive, both quantities increase together. All right. So if you haven't done this part already, what I would like you to do is stop the video, and I want you to classify each of these in using 2 or 3 keywords. So you're going to use either positive or negative. Then you're going to say whether there's no relationship, strong, moderate, or weak. And then you're going to say whether it's linear or non-linear. So these two go together, these two go together, or these 4 go together, and then the positive and negative go together. All right, so I'll demonstrate with the first one. I'm going to say that this is negative because it's falling. I'm going to say it's linear, even though it's not a straight line. There's not a perfect straight line, but it's a pretty good oval. It's a pretty thin oval. I'm going to say it's strong. And that's what I want you to do for all of them. You can stop the video and try them and then come back and check. I'm going to say this is positive. I'm still going to call it linear, and I'm going to call it moderate. I'm going to say that there's no correlation here. So when it's no correlation, it's not positive or negative, it's not strong, moderate, weak, it's just no correlation, it's not linear or non-linear. This one I'm going to say strong and non-linear. because there's clearly kind of a U-shaped pattern that is very thin. I'm going to say no correlation here. This is strong, positive, linear. That should be a straight line. I'm so bad at drawing straight lines. Let's see if I can draw one here. Okay, I'll have to work. All right, I'm going to say weak, negative, linear. I see a straight line falling down this way, and there's my oval. This one is non-linear, and it is very strong. I'm not going to say positive or negative because sometimes it rises and sometimes it falls. And then this one, I'm going to say strong and non-linear. And again, I'm not going to say positive or negative because sometimes it falls and sometimes it rises. Okay. All right, this last page here, these last 2 pages, that's an assignment for you to do. You have some data here. Age is your independent and earnings is your dependent. So independent, remember your independent goes on the horizontal and the dependent goes on the vertical. Don't put your axes on wrong. Don't do them backwards. All right? There's a little bit of extra information here, and I'm going to go over it before you start. So this was in the online activity, talking about an outlier is a point that is different from the rest or is far away from the trend of the data. And what you need to do is determine if there's going to be any outliers in this data set. So if I go back to this one, I might think that there's, in this particular question right here, I see if these 2 points weren't there, if you just cross those 2 off, I might call those outliers, and in that case, I would say this is a negative, moderate, actually it's getting close to strong, but a negative, moderate linear correlation. I don't have any other ones that I could do that on. I don't see in the 5th one, or the middle one, I don't see an opportunity to get rid of anything there. I'd have to get rid of far too many items. But these 2 here, get rid of those. They might be outliers. I would need more data values to do that with any confidence though. Like if I had some more data sitting here like this, doing all that, so there's more points. And then I had this one out here and this one out here. I would definitely say those are outliers and I would get rid of them. I would just cross them off. And then doing any calculations, I would get rid of them out of my data. I would just cross them off of the data set. Okay, so these last 2 pages are an assignment for you to do. And if you have any questions, please don't hesitate to contact me while you're doing it.